Okay, so got a question from the class today about this problem here, for practice 3.19. So here's what we got here. We're looking at, where are we here? Upon combustion, this is a sample containing carbon, hydrogen, and oxygen produces blank, blank, and blank. Okay, so let's go here and remind ourselves what's going on. So we have some, oops, let's get this in black. We have some compound CXHYOZ gets combusted with oxygen, right, to form CO2 plus H2O. Okay? Now, one thing we know for sure, that how many ever moles of carbon dioxide there are that many moles of, that's what X is, right? Because every little bit of carbon comes from there because there's no carbon over here, right? Same thing goes for this. It's not exactly how many ever moles of water there are, but you see that Y is related to how many ever moles we get of that. Okay, so let's go ahead and set this up and see if we can make some sense of it. Okay, mass. I'm also going to do another column for carbon and oxygen and hydrogen. Pardon the phone call. I'm going to take it. Hi, Mama. No, but I'm doing a video and I'm recording this phone call. Let me put you on speakerphone so you can say hi to my students. Here she is. Go ahead, Mama.
Hi, everybody. You have the best professor.
Mama. Mama, I'm going to go, okay? I'll call you back when I'm done with this video.
Okay, bye.
Love you. Bye-bye. Okay, so I'm going to leave that on there just because. All right, let's go back here to this video. Sorry about that, folks. All right. So, that was classic. Did you hear her mispronounce, Professor? 1.3109 gram sample. All right. 1.3109 gram sample. 1.3109. Where are we here? Produces 3.2007 of carbon dioxide. And 1.3102 of water. 1.3102 of water. Okay. So what's the formula weight of carbon dioxide? I'm going to pretend like I just looked that up. It's 4401. And what's the formula weight of water? 18.02. That's in grams per mole. That's in grams. This is in moles. All right, so I don't have to put those units over there. All right, and so how many moles of carbon dioxide are there? Let's go to red. Moles of CO2 are equal to the, that's an equal sign, 2, are equal to the mass of CO2, 3.2007 grams, divided by 44.01 grams per mole, is equal to 3.2007 divided by 44.01 equals 0.0727. Okay. Let's go back to this now. The moles of water are equal to 1.3102 grams per mole equals to, just a minute here, 1.3102 divided by 0.0727. Oops, nope, no. 1.3102 divided by 18.02 equals the same number, 0727. Okay. Okay, so now let's look at this. That means that, let's go back up to the empirical formula now. That, just 1 second here. What about our oxygen? Oh yeah, okay. So let's find out how many moles of how many moles of carbon are there? It's going to be 0.0727, right? Because there's a 1-to-1 mole ratio here, right? 1 mole of that gives 1 mole of carbon, so it's 0.0727. And the formula weight of that is 12.011. And so the mass of that, mass of carbon, is equal to 12.011 times 0.0727, because this is in grams. And this is, oh, it's going to be divided by, because that's moles, right? Oh, wait a second. No. That's grams per mole. It's going to be times moles. Okay? So let's multiply those two numbers. Times 12.011 equals 0.873. 0.8733. Okay, watch this. This is magic. Okay, how many moles of hydrogen are there? That's a little more. I'm going to go to a different sheet of paper here for this. I'm going to go back here for a second. There's 0.0727. Gotcha. Let's do this in red. 0.0727 moles of water. Moles of hydrogen. Moles of water. Looks like there's 2 for every one of that, right? So it's going to be that times 2. 0.0727 times 2 is 0.1454. And this is 1.008, right? So times 1.008. This is going to give us 0.1465. Okay? Now watch this. This plus this plus this is equal to, bam, that. Why? Okay. I'm going to add these two numbers up. 0.14656 plus 0.8733. And I'm going to subtract that from the original number, which is 1.3109 minus that, and this is going to give me the mass of oxygen now, and I haven't left myself enough room for it, is going to be, I'm going to put the mass down here, the mass of oxygen is equal to 0.291. And the formula weight of oxygen is equal to 16, so the moles of oxygen is equal to 0.291 divided by 16. 0.1819. Okay. All right. So here's what we got. We've got, this is now we've got the moles of carbon, the moles of hydrogen, and the moles of oxygen. So I'm going to write it down: carbon, hydrogen, and oxygen, and it's 0.0727, 0.1819, and 0.1454. That's the moles of these guys, okay? But these are not the lowest ratios. The lowest ratios are going to be divide all these by the smallest number. So I'm going to say n prime. That's the smallest number. I can see that's going to go in there twice, but I can't do the other. Oh, there's a point. There's a 0 here. Sorry, 0 there. Oops, that makes that the smallest number, doesn't it? That makes that the smallest number. All right. Let me go back here. That's a 0. That's a 0. Let me just make sure I got that right. 0.2291 divided by 16. Yep, that's right. Okay. So now we divide all these by that number, and that goes to 1. This is going to go to 4. This is going to go to 8. All right. You know what? I got these two numbers mixed up. Crud. These two are mixed up. Look at that. That was here. That's not oxygen, that's hydrogen. Okay. So this really, sorry for the confusion there, folks, but I'm going to leave it. I'm going to leave it as it is because it's correct. Okay, so C4H8O is the answer. Wow. Not pretty, but because we got our call in from my mother on that video, we're gonna leave it. So I hope that's helpful. Sorry for the long video, and I encourage you to actually watch the video and attempt it yourself, and then watch it again. So if you've got the patience for it, that'll be valuable to you.